New chapter of the CS1, that is operating system. In today's lecture, we are going to learn what is the operating system, what are the services provided by operating system, then information management and process management in detail. We frequently use the word operating system. But what is operating system? Students, if we have all the hardware devices of the computer system and all are connected to each other, but until and unless you install operating system on it, it won't work. It will not going to process your request. Now, operating system, it is nothing but a program which act as an interface between user of a computer and a computer hardware. Means if we have the computer hardware, then we have to install the operating system. Then and only then we can make a use of that hardware. Now, the major components of the computer system are first is a user of that system. Inside that computer, at the bottom, hardware. Okay, above that hardware, operating system is there, and then application programs are there. In hardware, we can say that all input output devices, memory devices are comes under this hardware part. Operating system, the program which is going to handle, which is going to operate this hardware system, and then application programs are there.
Sampada madam, sorry for the disturbance. Please unmute yourself.
Okay, sir. Now the next is the application programs. I mean, after installing the operating system, we will install some applications on it. For example, we have installed Turbo C programming, okay, application. So this is my application program. If I install MS Word, so that is also application program. So these are the major components of the computer system. Now, what are the services provided by the operating system? All what are the services provided by the operating system falls into the three categories. First is the information management, second is a process management, and third is a memory management. Now we are going to see all these services one by one in detail. First is the information management. Now, what is information management? Information management means managing the information. Whatever we are storing inside the computer system, we are going to manage it. We are going to arrange it in a proper way so that we can easily access that, we can easily update that. So that is the information management. So information management means it is a set of services used for storing, retrieving, modifying, and removing the information on the various devices. Now, what are the services? See, these are the services comes under the information management. But to accomplish this, we have to perform some operations, and that operations are called as a system calls. System call means what? It is a programmatic way in which computer program requests a service from the kernel of the operating system. It is to be executed on. Okay. Now, for the information management, what are the systems called we have to perform? First is a create file. To store the information inside the file, we have to create a file. Then create a directory. Then create link, open file, close file. Then read data from a file. Move the file pointer. Move file pointer means what? Suppose I want to write something inside the file, okay, at the second line. So what I will do, I'll move my cursor to the second line. So that is nothing but what? I'm moving my file pointer to the second line. Next, read and return the file status. Read and return the file status. See, sometimes we open the file, the message will come up, one pop-up will come that your file is read only. Okay, so that is nothing but what? It is giving me the status of my file, that my file is read only. This is also again performed by the operating system. Change working directory. Change working directory. Suppose if I'm working in one folder and I want to switch to the another folder, means what? I'm changing the working directory. So that also performed by the operating system. Means we have requested that we want to move from the one folder to another folder, or I want to close this folder, and I want to move to the new folder. Okay, so for that I'll send request to the operating system, and then operating system will revert back. Now write data from buffer to file. See, buffer to file means what? Whatever we type through the keyboards. I'm just giving the example how buffer works. See, whatever we write through the keyboard, it will not directly go to the computer system. First it will go to the buffer. Buffer is nothing but a temporary memory. Okay, and after that it will go to the file, or after that it will go to the disk. So to write from the buffer to your disk, that is also performed by the operating system. Next is a process management. Now process management, first of all, what is process? Process means program is in a execution. Now currently we are running the Zoom application. So we can say that for the operating system, Zoom is one process. I'm working on the PowerPoint presentation. Means PowerPoint presentation, it is in a execution, it is in a active mode. Okay, so for operating system, PowerPoint presentation is also one process. Process is a program under execution which competes for the CPU time and other resources. Now, when we execute or when we run multiple processes at a time, that time operating system has to keep a track of how many processes have completed their execution. Then operating system has to schedule that processes. Means operating system is going to prepare the schedule for the process execution. Again, it has to dispatch them one after another, so that once the process has complete the execution, it will start the another one. So that process is called as a dispatching. Okay, so that also done by the operating system. So this all comes under the process management. Now what are the system calls we need to perform, or the process operating system will perform to system calls for the process management are: first is a create child process identical to the parent. Child process means what? Suppose one process is one process is executing, okay, but to complete that process we need to complete one step, we need to complete another process, so that we can say that this is a child process for the original process. Okay, so create child process identical to the parent, then terminate process. After execution we need to terminate the process, so that is the process terminate of process call. Next is a wait for the child process to terminate. Wait for the child process to terminate means, suppose I want to close any application, or I want to submit anything on the device. At the time it will ask for the confirmation, do you want to continue, okay, or do you really want to do this. If I press yes, then and only then it is going to close that. For example, suppose I'm working on the MS Word application. Okay, I'm typing something on the one document. Okay, after that I click the close button. So before closing that application, operating system will give one pop-up, do you want to save the changes. So that is nothing but what? Child process. If if until and unless I click on yes or no, it is not going to terminate that MS Word. So that is nothing but what? Wait for the child process to terminate. Then change the priorities of the process. Priorities, see, will assign the priorities to the process. We can assign the priorities to the process. Means the process having highest priority will be executed first, after that the next one. Okay, suppose if you want to change that priority, that also operating system can do. Block the processes. If I don't want to execute any process, I don't want to complete any process execution on that device, then the operating system can block the process. Ready the process. Ready process means what? Make your process ready for the execution. Dispatch the process, then suspend the process, resume the process. Resume process, if you have suspended the process and if you want to resume that after some input output execute input output call, or so after some time, then we can resume that, delay the process and fork the process. So these are the system calls comes under the process management. Next is a memory management. Memory management, it is going to matters. Okay, now obviously for to do that, operating system has to keep the memory space available for the process. So memory management is going to okay. Before a program is loaded into the memory, okay, operating system will check locations available, free locations available for the storage, and then it will allocate the space for the particular process or for the information, depending on the size of the program. Now system, some of the system calls for the memory management. Okay, major two system calls are there. First is allocate the chunk of memory to the process, means first is the allocation, and the second one is obviously deallocation, means where we free a chunk of memory from the process. Okay, if the process is not exist anymore in the system, then we are going to free that memory block from the from your device. So these are two system calls comes under the memory management. Next is the components of the operating system. Major components of the operating system: storage manager is there, then process manager, file system, input output control system is there. So what is storage manager? Storage manager, it controls the utilization of the main storage by the different user of the program. Process management, process manager, it is going to handle your process management process, means response, it is going to handle all the responsibilities related to the process. File system, allocation of the memory space, deallocation from the memory space, keeping track of the free memory locations, that is nothing but a file system. And input output control system, what are the input output devices connected to your computer system? It is going to control, this is a IOCS, that is the input output control system, is going to handle, it is going to control the working of these input output devices which are connected to the computer system. Some other components of the operating system are, for another is the console manager is there, and log on and log off manager is there. Now console manager, it is going to change the operating system mode from the supervisor mode to the user mode or vice versa. Log off and log off manager checks the user's authorization like password and account. See, if you are using the multi-user system on your computer, for example, multiple users are there. Okay, so when you log in, it is going to check whether that user is authorized or not. How it is going to check it? By checking the validity of the, or by checking the your username and password. Next is a history of operating system. The first operating system was developed by the Microsoft, and that operating system was DOS. That is a disk operating system. Disk operating system, and it is a single user. Single user means only one user can operate, or only one user can use this operating system at a time. After DOS, a new OS was developed. It was having the graphical user interface, and that was named as a Windows 3.1. After Windows 3.1, Windows 98 was developed, and after that, after Windows 3.1, Windows 98 was launched, and it is a multitasking and GUI based operating system. Multitasking feature was started started in a Windows 98. Now Windows 90, some extra features we are discussing here of the Windows 98. First is it is a fast operating system as compared to the DOS, as compared to the all previous operating system, that is Windows 3.1, Windows 95, and DOS operating system. This is the faster operating system. It is easy to use since the graphical user interface is provided. So it is more easier for the user to use it. Web integration is there, means when you install the Windows 98, along with that it will install the browsers also. Multiple display support is there, power management is there, and universal serial bus is also there in the Windows 98. It is more entertaining and fun. Games are also there, so more entertaining and fun is there. And the most important, the fourth feature, that is help feature is also provided in the Windows 98. So if you stuck anywhere, you can take the help from the Windows 98. Help related to the how to use that Windows, or how to use their operating system. Next operating system is the Windows 98. Windows NT. Windows NT is a 32-bit operating system. Now, what do you mean by 32-bit operating system? We always use this word. The operating system is 32-bit, operating system is 64-bit. What do you mean by that? Yes, students? Okay. 32-bit operating system means it can operate on the 32-bit at a time. That is a 32-bit operating system. Now Windows NT, it is a multi-user, multitasking, and multi-threading. Now multi-user means multiple user can be there for your operating system. Okay, that is a multi-user. Next is a multitasking. You can perform multiple tasks at a time. For example, while typing on a MS Word, you can listen to the music, right? So this means you are running two applications at a time. Multitasking is there. Now multi-threading. Multi-threading, what do you mean by thread? See, multitasking means what? We are running multiple processes or multiple applications simultaneously. Okay, here I have given the example of the MS Word, means I'm typing on the MS Word. Okay, and at the time I can run this music player also on the same system. So means I'm running these two applications at a time. So that is a multitasking. Now what is multi-threading? Multi-threading means what? A task can be divided into the smaller unit, that is called as a thread. For example, now let's take an example of the MS Word only. Okay, we are writing something on a MS Word. When you are typing that word, simultaneously it is checking the spelling of your word also. It is changing the number of words at the bottom. Have you observed that at the bottom when you type anything, Okay, at the bottom it is going to change the number of words, it is going to change the number of lines. Means you are running only one application, but inside that application multiple threads are running. Okay, so this is a multi-threading. This concept is also there in the Windows NT. Another features of the Windows NT is virtual memory management is there. Virtual memory management feature is also there in the, means it supports the virtual memory concept. Then symmetric processing. Symmetric processing means what? It allows the various applications or various tasks to be scheduled on any CPU in a multiprocessor. Suppose multiple processor, if your system is having multiple processor, and if you want to run the multiple application at a time, so it allows the user to use any processor which is free at a time for the program execution. That is a symmetric processing. Next is a threading is there. Then preempted multitasking. Now what is preempted? Suppose one process is going on, one application is going on, and at the time or during that execution, suppose one high priority process has come for the execution. Then what the then what the operating system will do? It will stop the execution of the current process and then continue with the process which is having highest priority. Means what? He has preempted the execution of the current process and continued with the highest priority process. After completing the priority process, it will again come back to the current execution. So this is the preempted multitasking is there. And built-in networking. Networking, see, Windows NT supports the features for the networking. Okay, means we don't require any other operating system to be to be installed on the system for the networking feature. These features are incorporated in your Windows NT. Next operating system is a Linux. Linux, it was created by the Linus Torvalds, and it was developed in the 1991 and released the version of 0.02. In 1994, version 1.0 of the Linux kernel was released, and the current full feature version, that version is 2.4 version, and that was released in January 2001. Now Linux, the components of the major components of the Linux is, first is a kernel is there, then system libraries and system utilities. System kernel means which maintain all the important abstraction of the operating system, such as process and memory virtual memory. Okay. System libraries, it is a standard set of function. We call it the built-in function. Okay, all built-in functions are available in the libraries. Then system utilities, these are the programs that perform the individual or specialized management tasks. So these are the system utilities are there. Now features of the Linux. Features of the Linux. First feature, network. Linux is a network friendly. Okay, network friendly as compared to the Windows. Networking will be easy. Networking will be easy if you are using the Linux operating system as compared to the Windows operating system. Next, Linux is a multi-user. Again, multi-user support is there in the Linux. Linux is a open source. We always says that Linux is an open source operating system. Open source operating system means it is means we can change the code of the we can change the code of the operating system. Means not only we can use that Linux freely. Fourth feature is a Linux is a free, means we can use this operating system free of cost. But if you want to make the changes in the code of the Linux, that also we can do. So that's why it is called as it is a open source operating system. Now the types of operating system. First is a single program operating system. Means only one user program can be executed on the system at a time. That is a single program. Multi-programming, exactly opposite of the single program operating system. Multi-programming, we can execute multiple program at a time. Time sharing. Time sharing, now here time sharing means CPU time sharing. Suppose multiple processes or multiple programs are running simultaneously, then they can share the time of the CPU. For example, CPU's time is 30 seconds are there. Now, computer or operating system works in a microseconds. Okay, here I'm giving the example. Okay, that's why I said that 30 seconds. Now 30 seconds are there, and now three processes to be executed on this system. Then what they will do? Then what the operating system will do? It will share this 30 seconds within these three processes. That is 10, 10, 10. So this is a time sharing. After within that 10 seconds, the processor has to complete that process has to complete his execution. If the execution is not completed, then also processor is going to stop the execution of that current process, and it will move to the second process. That is a time sharing. Next is a real time operating system. Here the job have fixed the deadlines, and means here we are going to fix that the 10 seconds, within that 10 seconds processor has to complete the process one, and then that is a real time operating system. Next type is a multi-processing operating system. It is capable of handling multiple processor, not see multi-programming, time sharing, real time, or single program operating system. Here processor is only one, but in multi-processing, the computer will be having the multiple processor inside it. That is a multi-processing operating system. Multi-programming, one CPU, but multiple program can be executed. Multi-processing, processor are multiple processors are available. Now the next, now we are going to learn that services, that is the information management, process management, and memory management in detail. Now, first service is the information management. Information in the information management, two modules are important. First is a file system, and next is a device driver. Now, what is file system? See, file system allow user to create the files, create the directories in the system. It allocates and deallocates the space to this to this file by using the various data structure. Now, now what is file? File, it is a collection of related information. Okay, it can contain program and data. Suppose if I created one C program file, okay, let's say program.c++. So this is also my file, and if I create one MS Word document, so that is also one file. So it can contain the program and data. File is a sequence of bytes, lines, or record, and each file is having the name with the extension. See, when you saved any file, we have to give the file name, and the operating system will apply the extension to this. Okay, so every file is having the file name and the extension. Now the next concept is a block. Block means what? See, as I said, file is a collection of the data, collection of the information, and that information can be your program or data. A unit of a data is called as a block. Now, for operating system point of view, we can say that it is a block. But if you go with the hardware point of view, or with if we can go with the suppose disk point of view, then this block is called as a sector. Now, disk. See, it is a secondary device, and there are two major disks are there. First is a floppy disk, and another is a hard disk. Now, what is floppy disk? See, in the diagram, it is showing that it is a floppy disk. Okay, it is made up of the round piece of plastic material coated with the magnetic recording material. Okay, one rounded piece of plastic material is there, and it is coated with the magnetic material so that we can record our information, we can store our information on that. Then the surface of the floppy disk is made up of the concentric circle called as a track. See, that complete round piece, okay, where we are going to store this information, that in that disk, that rounded piece is divided into the some concentric circle, and that circles, each circle is called as a track. Each track again is divided into the sector, and inside that sector we are going to save the information. Okay, see, when we buy any new any new device, let's say, so suppose, let's take an example of pen drive. We need to format that. First we format that device and then we'll store the information. Now what do you mean by that formatting? Formatting means we are creating the sectors and tracks on that device so that we can save the information. Okay, so first we'll create a tracks on it. After that we create a sector of it, and then you inside that sector we are going to store the information. Now next, the hard disks. The hard disks, it is divided into, now here, see here it is shown that hard disks in short, it is nothing but a divided into the platters. Multiple platters are there. Okay, and each platters are divided into the sectors. You can see in the first diagram. You can see in the first diagram. See here, divided into the tracks. That is a concentric circle, and each track is divided into the sectors. Okay, and if you combine all the tracks, okay, all the tracks of all the platters of the same radius, then it becomes your cylinder. Now each each platter is having read write head. See here, in the diagram it is in the diagram it is shown that read write mechanism of the hard disk. Okay, now here multiple platters are there, then which are which are placed one above another. Okay, then on these platters tracks are there. Tracks are divided into the sector, and at the center one spindle is there. Okay, and it all this structure is attached to the one arm assembly. That arm assembly will have the read write head, read write arms, and at the top or at the one end of this arm there is a read write head. So using that read write head, we can perform the read write operation on that platters. Okay, now how we can perform that? One spinner is there. This spinner will rotate your platters. So when we move that platters, when this platter moves, rotates, okay, one particular sector, the sector from which you want to read or sector to which you want to write, that will come under that read write head, and these arms moves back and forth. Okay, so that it will come to the particular track, right? So when it comes to when the correct track or correct sector will come under that read write head, then and only then we can perform the read and write operation. And each platter is having a two read write head, one is above and another is at the bottom surface. Now as I said, when you want to read data from the particular sector, then we have to rotate the disk, and when we have to and to reach the particular track we have to move the arms, right? So time taken to move to the correct track is called as a seek time, and time to reach to the particular sector. Okay, how we can reach to the particular sector? By rotating it, by rotating our disk. So that time is called as a latency time or rotational delay. And activate read write head for the particular surface and read data from that sector or track. Okay, so time taken for this is called as a transmission time. Now file operation. What are the operations performed in the file management or information management? First, we know that if you want to read any file, if you want to write anything in the file, definitely we have to open the file. Okay, but to open the file, first we have to create the file. So first create a file. Create a file means what? When you are going to create a file, operating system will check whether the space is available or not. If space is available, it is going to create a file. Otherwise, it will give the message no sufficient space available. Then write to the file, reading a file, rewind a file, Rewind a file means what? It will bring your file to the initial position. Okay, that means we reset the content of the file. So that is a rewind a file. Next is a delete file. We delete the file from the memory. Next is the allocation method. See here, just now we have discussed that when you are going to create a file, operating system will check whether space is available or not. If the space is available, then it is going to allocate the space to that file. So now, what are the allocation methods we are going to use? Allocation method falls into two categories. First is a First is a contiguous and non-contiguous. Okay, or in another word, we can say that the continuous or non-continuous. Now, see, to allocate the space to the file, operating system has to maintain two tables. One is the free space table and another is the allocated table. Means in the free space table, it is going to keep a track of means um, it is going to keep a track of uh, how many space is available, and also it will maintain the starting point and end point of that free space. Similarly, for the allocated table, it is going to keep a track of how much space is allocated, starting point and end point also. Now, if you are going to allocate the memory space, if you are going to allocate the space in a contiguous, meaning in a continuous manner, then it is a very simple and easiest way. Okay, but if you go for the non-contiguous, then again there are two methods are there to implement, or two ways are there to implement that. First is a chain allocation and index allocation. Now, when you are going to allocate the space, when you are going to allocate the free space to the methods, okay, there are three possibilities. First is a first fit, best fit, and worst fit. First fit means what? If suppose file requires 7 blocks, and operating system goes to the block list and allocate the entry which blocks are equal to or more than 7. Then there is no issue. It is just going to assign that block to the file. Now, best fit for this method, free block list is to be sorted by the number of free blocks. It would choose that entry which is smallest among all the entries and which are equal to or bigger than the required one. In first fit, it is just going to check which one is the first available. In the best fit, it is going to sort it in the ascending order, and then it will choose the fit. Best fitted for the file storage. Then the worst fit, it allocates a free space that is equal to or larger than our requirement. So that is the worst fit. Now, as I said, for the non-contiguous allocation, there are two ways to implement that. First is a chain allocation and another is a indexed allocation. Now we'll see that chain allocation and index allocation one by one. Chain allocation, see here, just see the diagram. Okay, in the diagram, three files I have taken. That is file A, file B, and file C. File A is at the sixth location. So see, at the sixth location, okay, from this sixth location, my file A has started. Then it stores the, or it when you go for the chain allocation, okay, chain allocation means it is a non-contiguous. Non-contiguous means what? Your complete file is not at the one place. It is scattered at a different place, right? So obviously we have to keep the track of what are the places you have used. So first place for the file A is 6, and another is a 8. Means the first part of the file is A is at the 6th location, and another part is at, means second part of this file A is at the 8th location number 8. Third part is at the location number 4, and the last part is at the location number 2. So when you store the information at the sixth location, along with the file information, we have to use one pointer, okay, which is pointing to the next place. Okay, so in the diagram it is shown that at the 6, okay, location number 6, we'll save the information, and then we save the block number which is next to this current location. So here 6 is having the 8 part. Then if you go with the 8, 8 is having 4. 4 is having 2. See, 4 is having 2 and 2 EOF is there, that is the end of the file is here. Okay, if you go for the file B, first part is at the 5th location, then second part is at the location number 9, and the third part is at the location number 12. So location 5 will start with the file B for the file location. File location is holding the address of 9 also. Then 9 is holding the address of 12 and 12 is holding the EOF. So this is the end of the file B. Okay. After that, next, see some, you can see that location number 7, 11 and 14 is having free. Free means what? These are the free spaces. These are not utilized by any other file. Okay, so this is the chain allocation where we'll keep a track of the next pointer. Next is the indexed allocation. In the indexed allocation, we have to maintain one index. Okay, along with the information, along with the file, we have to maintain the index for that file. Let's say here in the directory, file B is there and index block is 24. Okay, now 24 will contain the address of all blocks which we have used for the file B. You can see in the diagram, that is block number 24 is holding 1, 8, 3, 14 and 18. Means your complete file B is divided into this block. Yes, any doubt? Someone has raised the hand. You can
Ma'am,
unmute.
can you show the previous slide?
Yeah, sure. Wait. Yes. Yes.
Ma'am, why in 15 it is written bad block?
Means that block is corrupted. We cannot use for the you cannot use for the storage. This is a corrupted block. That's why it is written as a bad.
Okay, ma'am.
Ma'am, can you
Thank you.
show page number 7?
Slide number 7.
Yes, ma'am.
Device driver, it is also one type of program which we need to install to make your hardware work. For example, if you connect any device, let's say if you connect any printer, we have to install the driver of the printer. Then and only then we can use that printer. Okay, so this is a device driver. Device driver, it is nothing but a program, okay, which is required for the hardware. Now in terminals, input output terminals are there. Terminals means what? The hardware which is connected to your computer system. Okay, that is your terminals. And input output terminals, input output devices connected to your system, that is a terminal input output. Now when you call the terminal input output, there are two types of terminal. First is a dumb terminal and second is an intelligent terminal. Dumb terminal means it can have the memory. Okay, means it is only for the storage purpose. No processing will be applied through that terminal. Okay, for example, keyboard is there, we are just going to enter the data, no processing is there. And intelligent terminal, processing will be applied, it is going to storage as well as for the processing. Means it is going to check the validity, it is going to check the validation. Okay, it is going to apply the validation to your data, whatever you are entering, it is going to check the validity. So these are the two types of terminal, dumb terminal and intelligent terminal. Dumb terminal, there is no processing. Intelligent terminal, processing will be there. Next is a process management. Now process management, what is process? Program is in execution, that we call as a process. Okay, now what are the use or what are the benefits of the using process management? It increases CPU utilization. Okay, means for example, if one process is running, okay, and if one process is running, okay, and during the execution, if it requires some data, or if that process is going to utilize any input output device, then definitely that during that time your CPU will be idle. Okay, so if you are using the process management there, then that free time of the CPU will be utilized for the another. So it will increase the your CPU utilization, and it increase the higher job throughput. Throughput means what? Output. Okay, it is going to increase the output of the process. Means during the suppose 10 seconds, if you are going to normally if you finish the one process, but if you are using the process management, then when the process one is looking for the any other resource to complete the task, during that time process 2 is completing the execution. So it's for that particular time you are completing the process 1 and process 2 time simultaneously, means it increasing the throughput of your CPU. Now process state. See, process, we know that program is in a execution. Now there are five states of the process. First, the new state. Okay, when you present your program to the CPU for the execution, then this is my new state. When the next is a ready state. When you create any new process, that will be a new process. Ready state, when you load that process to the CPU memory, okay, for the execution, then it will become the ready state. Ready state means what? My process is ready for the execution. Run state, CPU is running your process. CPU is executing your process. That time your state of the process is the run state. Terminate process, after the execution, when the CPU terminate, when the operating system terminate or close that process, that is called as a terminate state. Block state, if you stop the execution of any process in between, or if you put any process for the waits for the in the wait state, in the wait for the waiting, then we'll call it a block state. So these are the five states of your process. Now the next is a process control plans. See, when we are saying that the process management is done by the operating system. If you are running the multiple processes, then operating system is going to handle this multiple processing. Now, but when the operating system will going to handle this, then it will maintain some register for this. Okay, it will maintain some data for that particular process. Okay, now that the block which contain the information about the process, that block is called as a process control block. So when just now we have learned that the new state is there, means when you create a process. So when you create a process, that time operating system will create, or operating system will generate one PCB, and each process is having one PCB. That is a PCB means what? Process control block. And in that PCB we store the information about the process. First is a PCB pointer, then process state, process number. See, for each and every process will apply, we give the number. Okay, next is a PCB pointer is there. PCB pointer, it maintain the address of the next process which is to be completed, which is to be executed after this. So that is the pointer. Next is a process state. Process state, here we mention the state of our process, whether it is ready, run, block. Okay, next is a program counter, part of the program process belongs to. Next is a register. Here we have to maintain some register for the execution, that will be here. Memory limit means how much space we required for this execution. Limit, then starting point and end point will be here. And then next is the accounting information. Okay. Now context switch. See, here I'll give you before I start with the context switch, I'll give you one example. Suppose if you are running multiple applications on your computer system. Let's say you are typing something on a MS Word. Simultaneously, you are listening to the music. Okay, and suppose we are also doing recording on your PC. Okay, means three applications you are running. First is a MS Word, another is a music player, and third one is a recorder. Okay, Now, but we know that when your system is having only one processor, then one processor can run or can execute only one process or one application at a time, right? When but if the processor is going to run only one application and at a time, then how we can run many application at a time. So that comes the concept of the context switching. What the processor will do, it will execute some part of the MS Word, then it will move to the music player, it will execute some part of the music player, and then it will execute some part of the recorder. Okay, and this will done in a fraction of second. So it is taking her this processor is taking time to execute something and switching something, but it is happening in a fraction of second, so we feel that it is running simultaneously. So many times it happens if you are running so many application at a time. So your processor or then your program, then your computer will hang for some time. We'll say that my computer is hang. It means that it is taking more time for the switching purpose. Okay, so context switch means what? We are switching from the one process to another process. So when you are switching from the one process to another process, we have to make changes in this PCB. We have to change the process state. We have to change the process pointer. Okay, so here here I have given the example of the process 1 and process 2, that is P0 and P1. When you are executing P0 and that in between, suppose if you are switching to the P1, then we are going to save state in the PCB0. PCB0, it is a PCB for the P0. Then reload the states from the PCB1 so that we can start the execution of the P1. Means we'll make the P1 state from ready to running state so that processor can run this. After this, when we want to come back to the process 0, that is P0, then again we'll save the state to the PCB1 and then we'll load the PCB0 to the running state. So this is what the context switch means. We are switching from the one process to another process, that is called as a context switch. Next is a process scheduling. Process scheduling means what? When you are going to run multiple processes at a time, definitely we have to make a schedule for the process execution if you are running multiple processes simultaneously. Now, what are the objective for the for preparing the schedule for the process execution? First is a fairness. Second is a good throughput. Then good CPU utilization, low turnaround time, low waiting time, and good response time. Okay, so these are the objectives for the process scheduling. Now, what is turnaround time, what is waiting time, and what is response time, that we are going to learn that. Fairness means we have to apply the same rule or some same concept for the each and every for execution of the each and every process, that is fairness. Good throughput means good output. Good CPU utilization, CPU must be utilized in a proper way. That's why you prepare the process scheduling. Now, process scheduling technique, two categories are there: non-preemptive scheduling and preemptive scheduling is there. Non-preemptive means we have discussed this preemptive scheduling in this lecture only. Preemptive means what? We are going to stop in between, right? And non-preemptive, we are not going to stop anyway. Okay, so in non-preemptive, three techniques are there: first come first serve, SJN, that is a shortage job first, then deadline is there, and in preemptive, round robin scheduling is there, and response ratio scheduling is there. Now, first come first serve, the process which is come first for the execution, that will be go for the execution first. Okay, irrespective of the everything, it is just going to execute the process which is come first for the execution. Okay, here I have given the execution, here I have given the example, that is a P1, P2 and P3 is there. Okay, arrival time of this is 0. Okay, but in the sequence, first is a P1, so we'll take the P1 for the execution first, then we'll execute P2 and then we'll execute P3. Now see, you can see that in the P1 execution time, okay, execution time is 24. P2 require 3 and P3 require 4. So for if you consider P2, then P2 require only 3 microseconds for the execution, but it is waiting for 24 microseconds for the execution. Okay, so here the waiting time is very high. Okay, so we can say that waiting time for the P1 is 0 because a processor has started the execution with P1. Then for P2, waiting time is 24 because after 24 it starts the execution of the P2. And P3 execution time is waiting time is a 27. So this is the waiting time. Turnaround time means what? The time where the process is arrived for the execution and it completes the execution. Okay. Now for the turnaround time for the P1 is 24. Turnaround time for the P2 is 27 because it arrived for the execution at the 0 time. Okay, but it completed its execution at the 27. So the difference between this 27 and 0 is 27. So turnaround time is 27. And for P3, it is 31. This is a first come, first serve. Next is a shortage job first. Shortage job first means the process which require the less time, the processor will execute that process first, which is having the less time. Means in the, if you continue with the previous example, in the previous example P1, P2 and P3 is there. Out of this, P2 is having the less time. Okay, so processor will take the P2 for the execution first. Okay, so it will reduce the average waiting time. So this is the shortage job first. Next is a deadline scheduling. Deadline scheduling means what? See the time limit. See, in the deadline scheduling, we'll give the time limit. Okay, and within that time limit, processor has to complete the execution. Okay, if the job exceeds the deadline, it is said to be a deadline overrun. For example, in this P1 is P1 required 24 microseconds for the execution, and if the processor gives 20 microseconds for the execution, okay, then P1 has to complete the execution within that 20 seconds only. So that is a deadline scheduling. Next is a preemptive scheduling. In the preemptive scheduling, first is a round robin scheduling is there. In the round robin, we'll allocate some space, allocate some time for the execution. Okay, same time for the each processes. Then it will give opportunity to all processes to complete the one turn. After that, it will continue with the first one. For example, here I have taken the 5 processes: job 1, job 2, job 3, job 4, and job 5. And 5 seconds is allocated to this. So for in the first 5 seconds, it will execute the job 1. Then next, it will execute the job 2. In the next slot of, it will execute job 3, then job 4 and job 5 and so on. Okay. After that, it will again come to the job 1. That is a round robin scheduling. Next is a response ratio scheduling is there. Response ratio scheduling, here we are going to calculate the response ratio, and then depend on this response ratio will allocate the processor, will give that process for the execution. Now how to calculate the response time? elapsed time and the execution time required for the execution. Now process priority. We can assign the priorities to the processes. Now three types of priority we can assign. First is the external priority, internal priority, and a purchase priority. Internal priority will be assigned by the operating system. It's depend on the scheduling algorithm. This, for example, suppose if you are following the shortage job first, then the first priority is given to the process which is having the which require the less time. Internal, then next is the external priority, the priority which is assigned externally to the process, that is called as a external priority. And the purchase priority, in this higher priority process is changed at the higher rate to prevent each user from the firing a job at the highest priority. Okay, in this operating system has to keep track of the time used by the process and their priorities. So that is all about your process management and information management. In the next lecture, we are going to learn the third category, that is the memory management.